later just as a reference.
Wait, so it's called Math Desmos?
It's desmos.com. Desmos.com. Definitely want to be utilizing that software. Is anybody on their computers to see whether or not they can see me on Zoom? Because I do want to make sure you can see me before I start recording. Oh, it's not you. I have to be on my phone hotspot in order to make things work. There we go. Okay, Anna, can you see?
I don't, it might just be my thing, but no, I can't.
Okay, let me stop sharing and reshare.
Wait, why? Wait,
Okay, can you see now?
Is anyone have a laptop? Mine just might be weird.
Yes. Okay, yeah, go for it. Just see if you can see the screen. Oh, thanks, Jose. Thanks, John. Thanks, Jackie. Okay, can y'all see the Desmos screen?
No, I see you.
Okay, let me stop sharing and reshare. All right, there we go. Look at this nice class. Okay, here we go. Share. Okay, can y'all see Desmos? Yes. All right. So if you go into the little wrench thing to the upper right, you can see that there's a rectangular grid and a polar grid. The polar grid is on the right. If you choose that polar grid, it will let you graph R equals something in terms of theta. For instance, let me get rid of the graphs I have. So I was just playing. So if I wanted to graph the thing I have on here, I'm going to type in THETA equals, and I type in PI/3. And why isn't it liking it? Oh, I remember why. Because it doesn't like anything that's just theta, which is a drag. Okay, but that's okay. What if we type R equals pi/3? We get a circle. Does that make sense that we would get a circle with R equals something?
Yes.
What about that R equals 8 cosine theta? I'm going to need to make my grid bigger. There's a nice thing called Zoom Square. Do y'all see it?
Yes.
And it makes the graph look better. So what if we wanted to look at R equals 8 and then just COS, and then to get theta, THETA. And then you can see we have a circle. It's centered. We got centered at 0. Thanks, Aiden. And it has a radius of 4 if we're doing it in rectangular coordinates. What's another one that we just graphed? Oh, how about this one? R is equal to, R equals 3 over cosine THETA plus sine THETA. Then you can see we got a straight line. It does not give you a table, but if you look at say you're looking at the graph R equals 3 over cosine theta plus sine theta, it should let you get some values. Or not. It looks like I'm not getting any values if I just touch the line. It is fine by me, for me, if you use Desmos a lot, especially in this chapter. I want you to have an idea of what you're trying to graph.
I actually used it a lot in the college algebra class because they didn't really teach us anything. It was just
Oh.
play with some of these videos. Do it.
Oh, gosh. Uh-huh. Where do you see the table thingy?
Next to, for example, I did this and then it gives me these options and I click that and it gives me a table. I'm not sure if you can do that as well.
Let's see if I can put in a function. Because the only way I've known to use the table is backward, putting stuff in and then getting a function out. So 3, how about 0 pi over 6 pi over 4 pi over 3 pi over 2. How about that?
Paid off, you know? You're out here shooting answers.
The only hard thing about Desmos is square roots. But I mean, everything else is groovy, so. So you can see that we can graph cosine. In fact, we can do R tilde cosine. I think we can do this. Let's see. Theta tilde. I just type.
So like, how does that work? Like, how would you write that out? Like,
Oh, the 1/2 power is square root. 1/3 power is cube root. You always take the number that you're doing the root and it becomes the denominator.
yeah, like, okay, I never understood how it worked. It's just like,
So if you had the fraction 2/3, that means your 2 is in the numerator, so you're squaring, and you're cube rooting because the 3 is in the denominator.
so you're the cube root of the square root.
That's right.
Okay.
And you can do either one first. So yeah, you can play with a lot of stuff. Let's look at another one of the graphs in the picture. So the circle that I did earlier, if you have R equals A times cosine theta plus B times sine theta, where A and B are any real number, you'll get a circle, but let's see. R equals 2 cosine GHETA plus 3 sine DHETA. And you can see we get a circle. We're going to do that later today or next time. Let's see. What if we have a minus instead of a plus? Do you see that we still get a circle? So if 3 becomes negative, the circle just moves. What if A and B are the same number? Then we're centered at 3, 3. Do you see that?
Like if you have a circle that is centered on the origin, can you just take a circle that's centered on the origin?
That's easier to do in rectangular coordinates than it is in polar coordinates. But yes, that's pretty much what you're doing. You're just translating. This is fun. Let's look at a spiral. So let's see. If you have R equals a number, and I'm just going to use 8 plus any other number, I'm going to use -1 times theta. And I'm going to stop showing all the rest because it's getting in the way. And zoom out. Must be something else showing. Okay. I want to zoom out. And this is a spiral. Yeah, I think that's because of the negative. Yeah, it's very like the Fibonacci sequence. So this is just R equals 8 plus theta. You get graphs that you do not get with rectangular coordinates. So spirals. Another one that you get that's cool is called a cardioid. That's R is equal to, let's do 3 times 1 minus cosine theta. And let's zoom in.
How do you graph the Kelvin ratio?
Fibonacci sequence. So let's see.
I'm sorry, I didn't mean to get sidetracked with the class.
No, I love Fibonacci. It's like one of my favorite things ever. Let's see. Let's do it next time so I can prepare and have it nice. Okay, excellent. Well, we see a cardioid. That's R is equal to a number times 1 plus or minus cosine or sine theta. What if we change it instead of 1 minus cosine theta? Let's change it to 1 minus sine theta. It just moves. Do you see? It was facing to the right and now it's facing down. If we make it plus instead of minus, it flips up. And that's another reason why I really want you to use Desmos. You can see how little things change the graph. What about a limaçon? R is equal to A cosine theta plus B, or A sine theta plus B. R equals, somebody tell me a smallish number. 2 sine theta, and another smallish number. Smallish or smallish or 4. Okay, let me lose that one. Now, we've got a limaçon. Do you see that it's like a circle, only flat? If I make this number, the 4, a little bit smaller, oops, where did I go? Oh, it's my thing refreshed. Okay, all right, so if we go back, we have, what did we graph for? No, 2
Theta.
plus 4. Let's try R equals 2 sine theta plus 3. We're getting, the dip is bigger. Let's do R equals 2 sine theta plus 1. Now it flips. If the number in front of sine or cosine is larger than the second number, then you're going to get that little loop inside. So for instance, if we have R equals 3 cosine theta plus 2. I made sure that the second number was a little smaller. Oh, let's try that. So what if we have R equals 3 cosine theta plus 3? Okay, R equals 3 cosine theta plus 3. And it just lips in. So if we go the other direction, R equals 3 cosine theta plus 4, it's flatter. And if we go backward, r equals 3 cosine theta plus 2, we get the loop. So as soon as the second number is smaller than the first, we get that loop inside. When they're the same, we get a pucker. And when the second number is larger, we just get a circle that has a flat area. All of these are called limaçons. And you can tell that the French really did develop a lot of this because most of the names are French. The one I like the best is the rows. So anything, here we go. If we have r equals a cosine times something theta or a sine something theta. So let's do r equals 2 sine, what do you want me to put? What the smallest number in front of theta? Smallest, sure. Bigger than 1, smaller than 5. 4.5. Smaller, because my scale is smaller than that. Okay, 5/2 theta. I have to spell correctly. And do you see we get a limit, we get a rows. If the number in front of theta is an integer, then we get the number of petals equals the number if the n number is odd. So this one is, what is the, where does the 2 come in from the graph? Yeah, it's how long each petal is. So if I change that 2 to 3, now I'm going all the way out to 3. If I change it to 5, I'm going all the way up to 5. If we change the number in front of theta to an even number, then we get double. Instead of, with 5, you got 5 petals. With 4, you get 8. What if we do 2? We get 4. What if we do 6? Isn't that cool? The sine, let's look at a smaller number and see if we can tell the difference between the sine and the cosine. So let's see, I'm gonna get rid of the cosine graph just for a second. The sine graph looks like it's vertically oriented. Do y'all see that? What about the cosine graph? Yeah, the petals are on the y-axis with the cosine. With the sine, no petal is on an axis. So they're very similar, but with cosine, the petals are on axes. With the sine, they're not. Okay, that sounds wonderful. So let's do 5 and 5. In fact, let's do the Connect Math right now. Since we're on our computers. This is all, I'm taping all of this, so yes. So see what happens when we have 5 petals, we get a different result. So we're centered, we're symmetric with respect to the y-axis. Let's see what cosine looks like. It's rotated. So everybody go to Connect Math. At least on my computer, I can't do Connect Math on my phone. So if you can't do Connect Math on your phone, please sit with somebody who can, so that it'll help you later. So we're looking at 7.2. Start now. 7.2 is the section that requires you to graph. So that's why I want you to go ahead and do it, if at all possible. The first question, what do y'all have as the first question? Okay, mine is r equals 7. So I'm gonna plot, it makes me plot 6 points. I'm just gonna plot points that are exactly the same distance away from the pole. I think I have 6. So first you have to plot the points, check. You can't plot extra? Let's see, check. Yeah, I'm right there with you. And then I chose the image that looks like a circle. Here we go. And then you have to connect it one place and then connect it a second place. Okay, what about theta equals pi over 3? Oh, what is your second question? Four pi over 3? So if you had 4 pi over 3, you would start on 4 pi over 3 in the third quadrant, and you would just plot points on that. Well, it's going to be the same line. Theta equals pi over 3 means that I'm always going to have that angle pi over 3. But if I flip, if I keep going on that same line, I end up in the third quadrant at 4 pi over 3. Are y'all, is this working for y'all? Who's actually doing the problems on Connect Math? Who can do Connect Math? Y'all, I see phones. I'm so sorry. Oh, okay, so you're at least watching. Okay, so let's go ahead and do one more, at least one more. So R equals 5 cosine theta. 5 cosine theta, that's going to be a circle. Remember when we had R equals 8 cosine theta? That was a circle. And it's going to be, pardon? I think it's going to go, when theta is 0, cosine is 1, so R is going to be 5. When theta is pi over 3, cosine is 1/2, so that'll be 5/2, which it's not going to let me graph. That's wonderful. What about pi over 2? Theta is, that's cosine is 0, so we'll get 0. Okay, here we go. So we're going to use the little grapher. We get at theta equals 0, R is 5. At theta equals pi over 3, pi, oh, I forget, it's Connect Math. Pi over 3, we get R equals 5/2. At theta equals pi over 2, we get 0. At theta equals, let's go into the second quadrant. 2 pi over 3 is also a nice angle for cosine. 2 pi over 3, because it's 1/2 again, but negative. So we'll get negative 5/2. 2 pi over 3 pi. Let's do pi. And what will R be if theta is pi? What is the cosine of pi? I'm in number 3. Cosine is -1, so times 5 will be -5. How many points are they going to require? Let's see. Let's keep going. Do you see that we're actually plotting on top of the points we have? But that's okay. Yeah, so I'm not sure it's going to be kind to me. So let's do pi over 6. that'll be 5 times the square root of 3 over 2. And do pi over 4. That'll be 5 times the square root of 2 over 2. Okay, let's see if it'll let me go back. So I got 6 points finally. You plotted more than 6 points. Sorry, that was rude of me.
Still plot 1 and 6.
Well, it's being mean to me. Okay, and so I can see it's a circle. I have to click on one of the points and then click on another point. Okay, let's see. R sine theta, do you remember that R sine theta is just y? What kind of graph is y equals -2? A straight line, and it's a horizontal straight line. So let's see what we get. If theta is 0, what is the sign? Oh, I see what I'm doing. Okay, but that's fine. So yes, we get 0. If theta is pi over 6, the sign is what is the sign of pi over 6? Yeah, and we have r sine theta equals -2. I'm having to divide the -2 by sine theta to get r. So r equals -2 times the sine of theta, divided by the sine of theta. So that point at the origin has to be wrong. Okay, good. All right, so we've got theta equals pi over 6. What is the sine of pi over 6? And if we can't find the reciprocal of that, what is the reciprocal of it? Good, 2, and 2 times -2. All right. Let's plot that point. What if we do pi over 2? What is the sign of pi over 2? And 1 times -2. Let's do 5 pi over 6, which is 1/2. So I'm going to get -4 again. And I don't want to do pi. We don't want to divide by a negative. Divide by 0. Let's see. Let's do 7 pi over 6. All right, and times -2, we'll find the reciprocal of -1/2 times -2. What is it? I'm not wanting you to check my answer. I'm just plotting points. Oh, I see. I pressed the wrong thing. All right, 7 pi over 6 is 4. I checked the wrong button. Okay, and 3 pi over 2, sine of 3 pi over 2 is, and -1 times -2. I think that's 5 points. I just need to plot one more. So let's do 11 pi over 6. And let's see if it actually acknowledges that I have, it did, yes. Oh, I don't want the circle thingy though. I want a straight line. Yay. So it helped that I remembered that r sine theta is -2. But say I didn't remember that and I'm frustrated. Then I'm going to go to Desmos and type in r sine theta, r, oh, I see, r equals, makes me solve for r, -2 divided by sine theta. And you can see we get that same straight line. So let's go back. Are these all graphing in this whole section? Oh, this is, okay, so this is what we're gonna do after that, which I think is a lot more important, is look at symmetries in these graphs. So let's just look at the graphs that we've already done. The first one is a circle with the radius of 7. Do you see that a circle is symmetric no matter how you flip it? So let's look at the rules of symmetry, which they give us in question 5. If we replace theta with negative theta, what was the equation of that circle in the first one? Let's see, r equals 7. So let's see. Let's go back. We've got r equals 7. And we're going to let all of the thetas be negative theta. And we're going to see how it changes our equation. How many thetas do we have?
7.
Do we have a theta? So if I replace all the thetas with negative theta, have I changed the equation? So it is symmetric with respect to the polar axis. The polar axis starts at the center and goes out like the positive x-axis. If we replace theta with pi minus theta and nothing changes, then it's symmetric with respect to the line that looks like the y-axis. The line at pi over 2. Well, we don't have any thetas, so we're definitely going to be symmetric also with respect to this y-axis, which makes sense with the circle. And finally, to see if we have symmetry with respect to the pole, we're going to let every r be negative r. Okay, well, we've got r is equal to 7. I'm going to replace all the r's with negative r. So I get r equals -7. Let's look at that graph. Let's look at it in Desmos. Let's look at r equals -7. What do we still get? The same thing, because with r, it's a directional thing. If r is negative, it just means we're going backward. Well, if we go backward on every single angle, we're ending up with the same thing. So that's why a circle is symmetric with respect to everything. So let's see, what is this one? 8 cosine 5 theta. So if I let all of the thetas be negative, is cosine even or odd? Even, that's right. And if you plug a negative into an even function, what is that? What can you do? It gets rid of it. So that means cosine is always going to be symmetric with respect to the polar axis. Okay, what about replacing theta with pi minus theta? That's a fun one. So we've got r equals 8 cosine theta, and we're going to let all of the thetas be pi minus theta and see if the overall equation changes. Well, how do we deal with cosine of a difference? Oh, 5/8, thank you, thank you, thank you. So how do we deal with cosine of the sum of two angles? Let's do this. Since we have a difference. What is
It
cosine?
could also be 5 pi since it was the reduced 8 cosine 5 theta.
Mm-mm.
Okay, so
No, we're just taking the theta, which is the thing plugged in. Oh, actually, you're so right. So we want to do 5 times pi minus theta. Very good, Gavin. So that's going to give us 8 cosine of 5 pi minus 5 theta. And what is the formula for the cosine of a difference?
cosine alpha.
Good. And if this one is negative, then
Plus
plus. Good.
sine alpha sine theta.
Excellent.
Who's cosine and cosine or cosine and sine?
Cosine isn't friendly. That's why it changes SIGNs. Cosine always stays with itself. Sine is friendly. Sine, cosine, cosine, sine. It's silly. So I've got alpha is 5 theta, 5 pi. Beta is 5 theta. So I've got cosine 5 pi, cosine of 5 theta plus sine 5 pi sine of 5 theta. And what is nice here? What happens? What do we know, like, for instance, about the sine of a multiple of pi? So this is the same as sine of 0. Yes. And what is the sine of 0? Sine, because sine is it's the same at every multiple of pi.
Oh, okay, yeah, sorry. It was like 5 pi is not the same as 2 pi. So
Right.
okay, I was answering these.
Oh, I see. Yeah, we're in the other side of the x-axis, but we still have what value? 0. So this entire second term goes away. What is the cosine of 5 pi? -1. So this entire thing becomes 8. We still have a cosine of 5 theta, -8 cosine 5 theta. Did we change from what we started with? Or do we have the same thing? We ended up, when we plugged in pi minus theta for theta, we got -8 cosine 5 theta.
The original equation, you're missing the negative h.
That's right. So we don't have the same thing. And what we say is it's inconclusive. And finally, we're going to replace all the r's with -r. So we're going to let the same equation, we've got negative cosine of theta, r equals -8 cosine 5 theta, so that I get r again. And is the equation on the right the same? That's right. It's so that you would say the test is inconclusive. Let's see if we're right. Yeah. All right. Let's do one more on here and then I'm going to stop this. Use symmetry to graph the polar curve. So I'm going to cheat because I don't really want to do symmetry. So 5 plus 5 cosine theta. Let's look at that. 5 plus 5 cosine theta. Oh, it's a limaison. Great. So we're going to have points at 0. We're going to get 10. Then we're going to go from there. So, all right. I'm going to have the point at 0. That makes sense because cosine of 0 is 1. 5 plus 5 is 10. What is the next nice value for cosine? Or how about pi over 6? I mean, pi over 3. Because the cosine of pi over 3 is 1/2. So I'm going to get 5 plus 5 halves. That's 10 plus 5 halves, 10 and 5. That's 15 halves. Let's go ahead and do some of those other angles. What if we do pi over 6 over 6 over 6? There we go. What is the cosine of pi over 6? So I'm going to have 5 plus 5 square root of 3 over 2. Let's see if it'll let us plot that. It did. Yay. Okay, what about pi over 2? Because that was a good suggestion. What is the cosine of pi over 2? So we're going to get 5. And I think they'll only let us do one more point. Let's go ahead and do pi. What is the cosine of pi? And so we're going to get 5 times -1 is -5, plus 5 will give us 0. Now, let's see if this is sufficient. Choose the orientation. Let me make sure the orientation is right. Oh, heck, pardon my language. R equals 5 plus 5 cosine theta. So it's going to the right. So the orientation is to the right. Placing first position. First point. Let's see if it likes this. Oh, thank goodness. Okay, we're going to do one more, just I don't know why. 1 plus 5 sine theta is, it really looks, it's going to be a limaison also with this inner loop, which is pretty big. Okay, so let's plot some points. At 0, what is the sign? What is the sign of 0? Almost 0. And so 0 times 5 is 0, plus 1 is, and now let's do pi over 6. What is the sign of pi over 6? 1/2 times 5 is 5 halves, plus 1. 1 is 2 over 2. So that'll be 7 halves. Is that right? Then pi over 4. We just have to do 6 points, I think. At pi over 4, what is the sign? So we've got 1 plus square root of 2, and it's a 5 times that. 5 times square root of 2 over 2. Yay. And the next point was pi over 3. Yes. 5 square root of 3 over 2. 1, 2, 3, 4. Let's do one more point. Let's do pi over 2. The sign of pi over 2 is 5 times 1 is, plus 1 is 6. Oh, 1, 2, 3, 4. I thought this was our 6 point. Let's do pi. What is the sign of pi? So we're gonna get 1 again, plot point, and close this. And we know that the whole thing looks like r equals 1 plus 5 sine theta. Okay, it looks like a limosome and it's vertically oriented. Oh, let's see if that's right. Looks kind of right. Yay. Okay, so do you see how I want y'all to do this set? The thing we're going to spend the most time on is messing with these. I'm going to go ahead and close this, stop sharing and turn this Zoom thingy off.